G'day guys, how's it going? So in this video, we're going to talk about crates in Rust. So firstly, what are crates? Well, in short, a crate is essentially the smallest amount of code that you need to write for the Rust compiler to compile it, right? Now, it's made up of one or more modules. Now, most of what we've seen recently is multiple modules, but in the past, we've basically had just one main function, and that is actually been inside of a module. And that module is what we call the root module. Now, it's invisible to us, we don't see it. It's just that Rust basically says anything that's not in a module will fit in this root module, as long as it's in the file that's being executed, of course. And then there are two types of crates that we're going to deal with in Rust. One is a binary crate, which is what we've been seeing so far. That's the thing that runs at the command line. And then we have what's called a library crate. So let's see how modules work with crates. Essentially, you have this deliverable crate that you can have, and that crate will have one root module, as I just mentioned before. And then basically, if we think of the example that we've had in the previous video, we start implementing a module, let's say called the A module, and then that A module had other modules like the B and the C, and then the C had the D and the E, and we get this tree-like structure, right? So basically what I'm trying to say here is a crate can be made up of a tree of modules, starting with the root module and working our way down. Cool? Now, like I already mentioned, there are two types of crates in Rust. One is the binary crate, and the other one is a library crate. But what are the differences? Well, let's start with binary because we've been working with it so far. So this is where we can have one or more executables, or what we refer to as command line tools, or just tools in general. Each executable must have a main function. So inside that single crate, you can have more than one Rust file, but each Rust file must have a main function in order to execute it. And some common places where you'll see binary crates is things that start up web services or some special command line tools, things of that nature. Now, what is a library crate? Because we haven't worked with library crates just yet. Well, essentially, a library crate does not really have any executables, right? Essentially, it's just used to share code across multiple other crates, right? And then lastly, there is no main function required. It's just essentially code that you put into this crate, and then that's exposed to whoever wants to consume it. So that's all the info you need to know about crates. Now let's just jump into the code and create each one. All right, so what I've got on my screen is an empty folder called crate directories. And what I'm going to do here is I'm going to create two crates. One of them is our binary crate that we've been building pretty much the whole way along. And the other one is a library crate, right? Now, I'm not going to be using Cargo to do this. I'm going to be just creating the folders manually because I don't want Cargo to get in the way because it's to do with packages. And I'll get to that in the next video. So what I'm going to do is I'm going to create a folder under this crate directories, and I'm just going to call it app. And then I'm going to create another one, and I'm just going to call it, let's say, alib, right? To represent the library for our A module, let's say, right? So to create the app, usually we have a file that we call main. We go rs, and in here, we'll basically implement our main function. So we'll go fn main, and then we've got print line, and we'll just put out, hello world, whatever, right? And this is all we need in order to execute this crate, this app crate, right? So now I can just cd into the app folder, and then essentially I can just go rust c and then go main.rs, right? And when I do that, we're going to get that executable that was seen before. And when we run that, we know that we're going to run our executable. So this is the executable tool that will be generated based on the fact that we've created a file with main in it, and we've just essentially compiled it and then we've run the exe, right? So we've seen that before. There's nothing special there, but I just wanted to reiterate how to do that. Now let's look at the library, right? So what I'm going to do here is I'm going to create a file inside of the library folder, and I'm just going to call it lib.rs, which is what I've seen as like a common pattern for the default entry point for a library. Then what I'm going to do is I'm just going to copy and paste in an add function here, nothing special. And then what I want to do is compile this library crate, right? So to do that, we have to do a little bit more in terms of the Rust compiler. So I'm going to cd into alib like so. And then I'm going to run the same Rust compiler executable. But before I reference the file, I'm going to put in a flag called crate type. And I'm going to set this to lib, like so, right? So this tells the compiler that I want to compile this as a library crate, not as a binary crate. And then I just have to give it, the entry file to our library, which in this case is lib.rs. And it's going to give you a warning because, well, add's not being used anywhere. And we'll deal with how we can, we'll talk about how we can deal with this issue later on. But essentially, it's all compiled, everything's all good. And up here, we've got this thing called an rlib file now, right? Now, I'm not going to get into the details of what this rlib is because that's a Rust compiler thing, and that's a long course of its own that you could go down, right? But essentially, this is how we can create two different folders for two different crates. One is a library crate with just an add function in it, and then we compiled it using that -- create type equals lib, right? And then we've got our normal executable process, which we've seen before. So that's it. That's all I'm going to have for this video. So thank you for watching, and I'll see you all next time.